Alright, let's talk about 523 continuous subarray sum. We are given a list of non-negative numbers and a target integer k. We need to write a function to check if the array has a continuous subarray of size at least 2 that sums up to a multiple of k. And the multiple of k is n multiplied by k, where n is integer. The values of n doesn't matter. So it's basically asking us to find a continuous chunk of the array of at least size 2 that when you do the sum, let's say sum of array I to j, if we do a modulo with k, we can get 0. If we find such I and j, then we should return true. Find I and j such that. So that's pretty much what the question is asking us to do. So the example, we have 23, 2, 4, 6, 7. The target is 6. So we add, we find a continuous subarray here with 2 and 4. They add up to 6, which is 1 multiplied by 6. So we return true. The second example, we have 23, 2, 6, 4, 7. The target is 6. We add these three numbers together. We get 12, which is 2 multiplied by 6. So we should return true. The whole array itself is sum up to 42, so that's also one subarray that satisfies this multiple criteria. But we don't care about how many such subarrays existed. As long as we can find one, we should just return true. Yeah, so let's think about how we can solve this efficiently. So basically, if we can do a scan through the numbers, we can do some kind of cumulative sums, and with that we can efficiently calculate the subarray sum of any starting and ending index. Let me quickly note what this means. So if we could calculate a cumulative sum of which to be 0 to I, then if we just do one pass of the array to populate this, then if we want to calculate any subarray sum, it will be as simple as just look up two numbers from here, and take the difference. So if we can catch that, we can efficiently get the subarray sums. So but that sum could blow up to be quite large in the number. So instead of storing actual sums, we should think about how can we reduce that. So let's think about how can we determine the subtract of two numbers to be a multiple of k. So let's put them down here. Let's say that the first number is nj, the second number is ni, and we can decompose these two numbers into ak plus b for the first number, where ab is equal to div mod nj and k. For the second number, we can decompose that into some arbitrary integer c. No, it's a fixed one if we derive them from the div mod operation. And as a result, we can also have this property here, where b and d are actually in between 0 and k. So to take the difference to get to the subarray sum, we take the difference, which results a minus c multiplied by k plus b minus d. So to determine whether this is equal to the any kind of arbitrary subarray sum is a multiple of k, we know that the first term is definitely a multiple of k. It just boils down to determine whether the second term is a multiple of k. And then we have b and d sandwiched in between 0 and k. So the only possibility that b minus d is a multiple of k is that we want that b equal to d. That's the only possible case when these two the two number when they subtract each other to get a multiple of k. So that's what we want. So this tells us instead of storing the cumulative sum, what we should really store is the remainders by by taking a sum and divide mod by k. So instead of this, what we really want is let's call it Ri, which is equal to sum of this mod k. And then the question just boils down to we keep populating this. Whenever we calculate the result for one location, we go back and check do we have some previous location with the same number. If we have the same number, that we can make sure we are sure that the window by taking the different taking by those two values, the window. Okay, where do I take it? Yeah, we know that the sum from ij is a multiple of k if j equal to ri. So this the question really boils down to just caching the remainders. Or the other way around we can do is to, oh sorry, I'm blocking it. The other way is to cache the key value pair of the modular result and the location, and then do once we calculate a new remainder modular result, we just check whether the j and I are two apart from each other. If that's the case, they're guaranteed to be a window that satisfies the criteria. So that's the analysis. I guess for this such a simple question, it's kind of an overkill. Let's code this question up. Let's call it R, which is initially to be 0 minus 1. That's if we don't sum any number up. Let's call this M. R is the remainder. We iterate over once and calculate this Ri here. And we will want to do a modular, but there's a catch that if k is 0, we don't want to do this. Then we can just query this map whether we have seen such a remainder before. If we do see such a remainder, we just take the difference between the index and see whether we can form a window of size at least 2. So that's based on this condition, we go to the let's actually do this. If count, if we have seen such a remainder before, then we just try to compare the difference. I minus the last location. If that's greater than 1, we return true. Otherwise, let me use a bracket to make this more clear. Else, we just remember the location, this current location where this happened. Alright, so in the end, if we don't find such a window, we should just return true in the end. Or return false in the end, sorry. Okay. So we have a hash map that catches the remainder of a continuous sum up to the current location, the i's location, and map it to the location I. It's initiated with 0 to -1, means that we take none of the numbers, we can sum to the remainder as 0, and then just gradually populating this R of I with linear scans through the whole array. And for each number we add, we updated this modular here. If we have seen such a modular before, we then look at the I and j index differences. If they are larger than 1, so we can form a window subarray of at least the size 2, we should return true. Otherwise, we just remember the location for such a remainder. And in the end, we just return false. Looks right to me, so let's try submit this. Okay, it's working. Alright, so this is the question 523, continuous subarray sum. The question for this code, it will be linear in both time and space. Yeah, actually linear in time and constant in space. No. So it's order of n as number of elements in time, and the space is order of k. The target, that's the order of the space complexity of this hash map. Yeah. So that's the question for today.